Welcome to Dear SQL DBA, a podcast and YouTube show for SQL Server developers and database administrators. I'm Kendra Little from SQLWorkbooks.com. Today, we're talking about how you can, if you need to, sometimes remove hints from code executing against your SQL Server, even if you can't change the application itself that's sending the code to the SQL Server. This is episode number 43. Here's today's question. Dear SQL DBA, our ERP system runs a lot of ad hoc queries with poor performance. The software vendor is unwilling to help. Essentially, they're using query hints that are detrimental to performance for our scale. Is there a way to exclude certain hints from being used? For example, we have a query that returns 118 rows. It has a fast one query hint in the version running from the application. Without the hint, runtime is under 2 seconds, but with the hint, runtime is 6 minutes. It performs an index seek when the hint's in place that involves almost 120 million rows. This is a fun one, and this is the thing with hints. Sometimes we use hints to solve a short-term problem in one situation, and that's great, and it makes our query fast for the problem we're trying to solve. But if that code with the hint stays around for a long time, what made it fast before may eventually make it slow as the data distribution changes or the amount of data changes. It's really tough doing this. And honestly, the problem isn't even just with hints, it's actually with complex T-SQL. We make choices about how we structure the T-SQL, and what makes a query fast can change over time. With hints, they might seem like they're just suggestions based on the name. It's a hint. But a hint isn't something that SQL Server can just look at and say, oh, well, I'll follow that hint if it's faster. For example, this fast hint. I love the fast hint because it sounds like you're saying, hey, SQL Server, I would like you to make this query fast, right? We want all our queries to be fast, and SQL Server wants to make all of our queries fast. The thing with the fast hint is you have to give it a number. In the case of our questioner, they have an ad hoc query where it's fast 1. And what that 1 means is you're saying, hey, SQL Server, I want you to optimize this query to try to get me back 1 row as fast as you can. Even if it makes the duration of the whole query take longer, just give me back that 1 row ASAP, and then, do what you need to get the rest done. The fast hint sets a row goal for the number of rows that you specify for your entire query. And in some situations, like if you're getting a big set of rows back, but you can stream the results back and maybe you're only going to display a certain amount of them, you might set a row goal for the amount of rows that you're going to display if you can quickly show those even while the query is running. So there's some situations where this hint might make sense. In the case of our questioner, it sounds like someone made this fast during, testing somewhere, and then it didn't stay fast at their scale. For their scale of this code, which is run on a lot of different client systems, this hint, which is forcing a row goal, this hint just isn't making sense anymore. If you're in this situation where you can't change the code, these are ad hoc queries being issued from an application, and they don't even have the source code, much less permission to recompile it. In SQL Server, you can create something called a plan guide. A plan guide can work for stored procedures because sometimes you don't have permission to change stored procedures either. It can also work for ad hoc queries. You can create a plan guide that says, okay, if you see this T-SQL, I want you to add a hint to it, or remove a hint to it from it, or even you can replace hints if you want to. So you can say, recognize this T-SQL and change what's happening with the hint by either adding, removing, or replacing. And this can be really, really cool. Plan guides, they have kind of a rough reputation in SQL Server, and one of the reasons is that they can be a little frustrating to use. It can be tricky to get your plan guide to work. There are some pitfalls, and you can avoid them. And the important thing is to have the right code to get the right copy of the T-SQL that needs to be matched, and also to know what syntax to use if you want to remove a hint. It's not necessarily that obvious. So let's take a look at a quick demo. And if you're listening to the audio version, I will totally talk you through the demo. And in the notes on the podcast, on the description, I'll put a link to where you can find the sample code. So if afterwards you want to go grab that code and play around with it, you totally can. For our demo, I am using the small Babby Names sample database. I have this sample database up on github.com. This is the little version of the database, and I have already restored it to my SQL Server instance, and I've put a hack in place. I created a crazy, hacky, non-clustered column store index because I'm a lazy person and I'm just reusing some demo code that I used for a previous episode of Dear SQL DBA called Batch Mode Hacks for Column Store Indexes or for Performance, where I showed that there are some ways that you can fool SQL Server into using batch mode on operators by creating a fake column store index if you don't really want to use a column store index, but you want to get batch mode. So what I've done is I've already created this crazy non-clustered column store index with a hack that Itzik Bin Ghan wrote about, where I created a filtered column store index, but with this crazy filter that makes sure no rows are going to go into the column store index, where I created the column store index on the first name ID column of the ag.firstname by year state table, but then I said where first name ID equals -1 and first name ID equals -2. Now, no row can have first name ID have two different values, so no rows are going to get in this column store index, but it does mean, at least in my current version of SQL Server, I'm running this against SQL Server 2016 Service Pack 1, Cumulative Update 2. It does mean that SQL Server can use batch mode on queries that run against this table. I have a command in here to clear the procedure cache for the database. That's just if you want to rerun the demo. And I'm using the new 2016 command, alter database scoped configuration, clear procedure cache. That's a database level command that clears the cache just from my current test database. I'm not running it now because before we got started, I faked out an application and I ran some scripts from PowerShell. And I say it's a fake application because my PowerShell is terrible, but it gets the job done. What I did in PowerShell is I had it run a query against the Babby Names database 3 times. The query that it ran starts with a CTE called running total. This is the same query that I talked about in the Batch Mode Hacks podcast. And what it does is it has a couple CTEs. It has running total and then running total plus lag. And it takes a threshold parameter and says, I want to see when a name broke through this threshold based on a running total partitioned by first name ID, state code, and gender. The key thing to know about this query is the version running from our fake PowerShell application has a query hint in it. The query hint says, option, ignore non-clustered column store index. Now, when I have this query hint in there, when the application, the fake application, runs this, having this hint in my current version of SQL Server, it means SQL Server can't use batch mode operators. If I say option, ignore non-clustered column store index, I get all row mode operators. And it means in this case, I don't get to use the awesome new window aggregate batch mode operator that we got in SQL Server 2016. This query takes a little over 20 seconds to run when it's running everything in row mode and doesn't get to use that awesome new operator. And my PowerShell script ran this 3 times and measured the duration, and it took just over 70 seconds according to PowerShell. Now we're going to look in our SQL Server execution plan cache and see what SQL Server saw for this. We ran it each time, by the way, with the threshold parameter set to 100,000. We're looking at sys.dmexec query stats. And that's a really awesome dynamic management view because it'll tell us things like, what is the total worker time that's been used by a query? Worker time is CPU time. So I'm converting it into seconds because we get it reported in microseconds. And I'm also looking at the execution count and figuring out, okay, what's the average amount of seconds of CPU that it uses? I'm also looking at things like duration and logical reads. I'm joining to a dynamic management view called sys.dmexec SQL text. That is so that I can say, hey, I want to see the information for a query that has running total somewhere in the T-SQL, right? I don't want to look at all of the information and execution plans for queries and cache. I want to get the runtime and duration for this problem query that I want to look at, and I want to get the exact T-SQL that it's running. Because if I'm going to create a plan guide, I've got to get the T-SQL with the right spacing, formatting, and capitalization in the format that it's being run. Because when I create a plan guide, that I have to tell SQL Server, hey, match this T-SQL. And it cares about spacing and capitalization. I can't just retype in the query. I'm also connecting to sys.dmexec query plan so that I can see the query, the cached query execution for this if I want. So when I look at my cache in SQL Server, I find that for running total, I want to find the plan in my cache that has the words running total somewhere in the T-SQL, and I found it. Sure enough, it's run 3 times. And when I look at the elapsed time, on average, it takes 23 seconds for it to run. And that matches up with what I saw in PowerShell. It uses 76 seconds, almost 77 seconds of CPU time each time it runs. That can happen if our queries go parallel, and I can see information about the average logical reads as well. And it looks like actually in my script here, I had a little math problem in my logical reads where I was converting it inappropriately. We're gonna just fix this on the fly and rerun it there. So please pardon my poor math on the average logical reads there. One thing that my query does is for the T-SQL itself, it casts it for XML path. And the reason that I'm doing this is to make it easy to click and open in a new window with all the formatting in it. So I'm casting that. This is why I said having kind of the right code to get the T-SQL helps, because I want to get those returns and the spacing exactly. So if I open my T-SQL in a new window, I get all of that there and I can copy it out. And this is kind of a long query. One interesting thing too, this isn't, I made this, I ran it from PowerShell as not a store procedure, as an ad hoc query on purpose with a parameter, because the way this T-SQL displays, at the beginning of my T-SQL, I've got in round parentheses at threshold int, I've got information about the parameters tucked into my T-SQL in the DMV, and that's very useful. I need that. So I'm going to select this whole blob here and copy it to my clipboard, and then go back and paste it into a statement that runs sp create plan guide. When I run sp create plan guide, I've got to give my plan guide a name. So I'm naming it removing hint. And then I have a statement parameter. And I'm telling it what T-SQL to look for. I'm going to paste in that whole big blob that I copied from my T-SQL, but I do have to fix it up a little bit. I can't just leave the parameters at the beginning. I'm going to highlight my round parentheses with threshold end, and I'm going to cut that out to my clipboard. And I'm going to scroll down. I specify a different parameter called params, which is where you tell SQL Server, okay, when you see this T-SQL, it's going to have these parameters in it. So I'm going to paste the parameter declaration in there, but I do need to remove those round parentheses. We do not need those round parentheses. One little weird thing to know here is that thing about formatting and capitalization and stuff, it matters even in the parameters too. In my case, int was not capitalized, so I need to leave that lowercase. That's why I would say avoid retyping with plan guides as much as you can. Now I have some other things I have to fix up in my query. There may be things that you have to fix, like if you have quotes, you may have to go in and double quote stuff to make it valid. In my case, I have some greater than, less thans that were turned into ANGT semicolon. So I've got to go in and type over and say, okay, oh, that's a greater than there, and here's a less than there, and another greater than here. So I have to do some fixing up of quotation marks and anything else where the T-SQL has been garbled a little bit when it was stored in the DMV. My type for the plan guide, there's actually multiple types of plan guides you can make. This is just one of 3 types, the type I'm doing here. You could also do different types of plan guides that do things like force parameterization or use simple parameterization. Those are called template plan guides. Or you can do plan guides that freeze an execution plan and say, always use this specific plan for this plan guide. So this is what I'm doing here is changing hints, and I'm doing it with ad hoc SQL. So my type here is SQL. There's a module or batch parameter, and I'm saying that's null because I'm not referencing a stored procedure. You can create this type of plan guide, and instead of looking for ad hoc SQL, you can make it apply against stored procedures. That's just a different case. And in that case, it's kind of easier because you can just look at copy the exact formatting of the text from the scripted stored procedure, right? But it's a little harder when it's the ad hoc SQL. So I've got type is SQL, module or batch is null, params is threshold int, and then here's where the magic is happening. I am saying at hints, the hints parameter on sp create plan guide, set that to null. When you say hints equals null, I have in the T-SQL, I gave it to match, I have included the hint that's in the application, the option ignore non-clustered index. So what I'm saying with hints equals null is delete that query hint. I could choose to specify a different hint here in hints. I could say use a maxstop1 hint instead. And in that case, it would replace the hint with maxstop1. So if I actually wanted to keep the hint in there and then add another hint, I would have to specify in my hints both ignore non-clustered column store index and then a different one as well. So it's going to overwrite the hints with whatever hints I specify. And I'm saying hints equals null. So let's see if I got my syntax here right, if I got all those little greater than and less thans. And sure enough, I've run my SP create plan guide and it says commands create completed successfully. This only means that I didn't goof up the syntax with my SP create plan guide. This does not mean my plan guide is necessarily gonna work. We can look at and validate the plan guide. There's a dynamic management view called sys.fn validate plan guide that will try to see if it detects errors with our plan guides. And I'm gonna run that for all of the plan guides. And I see removing hint does exist. There's no error messages coming back from sys.fn validate plan guide. Now that still doesn't mean that my plan guide is necessarily going to match anything or be used. It just kind of gives me an indication that it doesn't look like my plan guide is actually like failing, right? So it's a small, a small solace. I'm gonna go back to my PowerShell script and I'm gonna rerun the whole script that took 70 seconds to run the query 3 times. And I'm starting up the script again. We're gonna run this query 3 times in a row once again. And we're gonna see if we can tell, did our plan guide work? Now, one good indication is that my script has completed in just 11 seconds this time. It was much faster running the query 3 times this time, but let's say we couldn't see that from the application. I'm gonna run the same query that runs against the execution plan cache and looks for, I wanna see a query that has running total in it. I wanna see that query and information about how many times it's run, how many logical reads it did, how much CPU it used. When I run this, I can see that it sees that my query has run 3 times. This should give us pause. Wait, I've actually run my query 6 times. Earlier, it ran 3 times and now I ran it 3 more times. Why does this say 3? When you create a plan guide to match text, if it matches text in the execution plan cache, it will clear that out. It doesn't clear your entire procedure cache, just the stuff that it matches. And this is kind of fair because we're saying, hey, when you match this text, do something different according to our guide. So whatever plan is in cache, we want a new plan that we want for the guided plan the next time it runs, right? We shouldn't be leaving that in cache. So when I created my plan guide, I did it properly and it matched to the exact T-SQL in cache. Got lucky, it matched, I didn't screw anything up. And at that point, it cleared out all the information for those previous runs. So my information on the 3 runs is just the 3 most recent runs. My averaged elapsed seconds, my average duration per run is now 3.7 seconds, and it's using 13.6 seconds of CPU time on each run. Well, how can I be sure that it really, I mean, maybe it was just a coincidence that it was faster. I can tell if the query used my plan guide by looking at the cached execution plan. My little query here that's looking at sys.dmexec query stats is also joining to sys.dmexec query plan so that I can open up and look at the cached execution plan for the query. I can see a couple of things, like I have a window aggregate operator that appears in the plan. And when I look at the properties of that operator and actually open up the properties pane, which is a wily beast, I can see that that operator executed in batch mode. This is that new batch mode window aggregate operator that's super fast. So I did get my batch mode, but I can even more specifically tell that my plan guide got used. Highlighting the select operator in the execution plan and looking at the properties of the select operator, if a plan guide was used, you will see in the properties the plan guide database. This was in the Babby names database, and then the plan guide name. The removing hint plan guide was applied successfully to this query. If I didn't see plan guide DB and plan guide name in my properties on the select operator, then that would mean, hey, a plan guide did not get used for this query. How many times has my plan guide been used overall? Well, my execution plan certainly doesn't tell me that. To tell that information, I would need to set up an extended events trace in SQL Server. And you can create one of these and use a bucketizer to say, hey, count how many times this plan guide has been used successfully. So to tell how many times a plan guide has been used to compile a plan, I've got to do a little more legwork. My DMVs don't tell me absolutely everything. If I want to get rid of my plan guide, I run SP control plan guide with operation equals drop and give it the name of the plan guide that I want to get rid of. And now that it's dropped, if I want to say, I don't want to mess with that query anymore, because, hey, I mean, just like anything else, I can make things slower with a plan guide as well as make them faster. If I wanted to do that, or if, say, I was about to run an upgrade and wanted to clean up all the duct tape that I'd put on stuff, I can do that with SP control plan guide and drop my plan guide. A couple of warnings about plan guides. You do need to be careful. Plan guides can create dependencies. Let's say I created a plan guide referencing a stored procedure, and then I forgot about it. And maybe I didn't mention it to anybody. Let's say that I left it in place and now an upgrade comes along and it tries to drop that stored procedure. It's going to fail because I've created a plan guide referencing that procedure. If you create plan guides, you need to make sure that you don't also cause confusion and failed upgrades. You need to treat these plan guides as code. Yeah, they're kind of a special kind of code that you're tacking on to the database, but they are code. And if you have multiple environments, test and production, it needs to be in all environments, including development. And the developers need to be aware of these as well. If you're in a situation where you're doing this on a vendor database without permission, I highly recommend that you have a good, strong process around this and you have a way to clean up your plan guides before you run any kind of upgrades against the system. Even if you don't have the dependencies problem, you might have a situation where the plan guide would be hurting you afterwards instead of helping you. You need to test them and make sure that you still need them. So I would just clean them out before you run any changes and then put them back afterwards. And of course, I'm not recommending that you violate any agreements with any of your vendors ever. Absolutely not. But you have absolutely free will. So thanks so much for the great question. And I actually got, just today even, I got another question that was like, hey, can you do some demos on plan guides? And I was like, yes, I can. And I'm going to record one today, in fact. So thanks, guys, for the requests. If you have a question for Dear SQL DBA, hit me up at sqlworkbooks.com/ask. And even if you don't have a question for Dear SQL DBA, head on over to sqlworkbooks.com and sign up for a free course there. Thanks so much for joining me this week for Dear SQL DBA. I'm Kendra Little, and I'll talk to you again next week.